Okay, now the other half of combining like terms is what's known as simplifying expressions. Unfortunately, in algebra, you're not always going to have a like term situation where you only have two like terms and nothing else to deal with. And it's not very realistic to just have x squared plus x squared and expect it to stay that easy. And so I have written out a very lengthy problem from the book that is showing you how to and where it might be useful to simplify your expression. Now remember that this entire set of terms is considered an expression. Terms added or subtracted together are an expression. And we need to figure out how to make this maybe look a little less nasty if we can. So we're going to look through this expression and see if there's any terms that are alike that we could maybe merge together so that we don't have something that's 1, 2, 3, 4, 5, 6 terms long. That's just way too long for anybody to deal with. Alright, so looking through this, can you find any of the terms that are alike? And if so, how many terms have partners? Hopefully you've had a moment to look through that. I see 5 terms that have some match somewhere. And so there are a couple ways that we could solve this. Now, your textbook recommends that you rewrite the problem so that it's easier to see where things are. Sometimes this is good. My concern with rewriting a problem completely is sometimes you miss a term, but I will show you a couple different ways that you can maybe make this easier to solve. So first we're going to look through and we're going to see which of these terms are alike. I see 2xy squared, that's an alike term, 3xy squared, and 4xy squared. Those are all the xy squareds. So we're going to take those, and according to the textbook, you could rewrite this, and you can make sure that these are all next to each other, which makes them a little easier to solve. So 2xy squared plus 3xy squared plus 4xy squared. Now if we were to do the math of that one really quickly and just get it all solved and then not have to deal with the length so much, we do 2 plus 3 plus 4. Well, 2 plus 3 is 5, and 5 plus 4 is 9, so we have 9xy squared. So if we combined all of those like terms, we have 9xy squared. And so over here, let's say we're going to finish solving the problem over here. We're going to write 9xy squared. Perfect. Then we're going to come back up here and we're going to look through for any other like terms. We have 4a squared. Oh, and according to the book, it could be helpful to cross these out once you've dealt with them. So we'll cross those out. Perfect. Now we have 3 terms left, and 4a squared. That's ab cubed and ab cubed. We don't have a partner for 4a squared. So 4a squared just kind of comes down and gets to hang out with 9xy squared. That's nice. Not too hard. Alright, and then we've dealt with him, so away he goes. And then we have ab cubed and 10ab cubed. So we're going to deal with those two. My nice purple. Look at that. It's a gradient. Isn't that so fancy? Anyway, we have negative ab cubed and negative 10ab cubed, so let's write those out over here and solve them. So negative ab cubed minus 10ab cubed. Well, what is negative, oh, let's pretend there's a little imaginary 1 in there. Negative 1ab cubed minus 10ab cubed, that would be negative 11ab cubed. So that takes care of those terms, which brings us over here to negative 11ab cubed. Now we look at this problem and we say, is there any other like terms that could be merged together to make this any simpler? We've gotten it down from 6 terms to 3 terms, which is awesome. Is there any way we could make this simpler? The answer is no. There's nothing else that is alike that we could add together, so this is our final answer. Alright, so that is one way to do it with this whole rewriting aspect. I mean, it can be very helpful. If you don't feel like you can confidently do something in your head and you're looking at a ton of terms and you're like, I don't know what to do, then rewriting the like terms down here, adding them together, and then creating a new problem off to the side can be very helpful. If you feel like you've got a pretty good handle on being able to do like -1 minus 10 without having to write it out, then we can also do another way to keep track of all of our terms. And so on this problem, I will show you one little thing that I enjoy doing. Alright, so here's another problem we're going to solve. We got to figure out all the like terms and add them together. I should have added an equal sign over here so that we know we're supposed to solve it. But there we go. Alright, so we have 1, 2, 3, 4, 5, 6, 7 terms this time. We want to find all of the like terms and then add them together. Well, if you aren't into the whole rewrite everything all over again, you can look through this and you can decide on a symbol for each of your terms. So let's see, x, y, z cubed. That's a pretty good term. Let's find any other x, y, z cubed. That's y, z, x squared, x, y, z cubed, there it is. And x squared, a to the fourth, yz. Those are the only two. Now, if we don't have a handy dandy red highlighter, because most of us aren't walking to school with a red highlighter, let's pretend that all we have is the color black to work with. So I have to get rid of my red. How sad. Okay, that's a y. Alright, so in this case, I could add a little star next to these two like terms and say those two are alike. And then looking through the rest of it, you want it to be something that's not going to be confused with anything else. So do not use X's. Probably don't use circles. Those could look like zeros, but a star is pretty safe. You star those and then find the other like terms. So yz, that's x squared, a4, yz. So we have two yz's. So in this case, I'm going to do a little, I could do a square. Ba-doop. And a square. So I can keep track of which terms are alike. Now on the next one, x squared, that one doesn't count. So I'm going to do a line with some like fireworks sticking out of it. That seems pretty good to me. And then a line with some fireworks. So that I can just look through it and be like, okay, I have 2 stars, 2 squares, and 2 starbursts that I'm going to add together. Alright, so then looking at this, 3xyz cubed plus 5xyz cubed equals, 3 plus 5 is 8. X, Y, Z cubed. That's pretty good. Now moving on to the squares, we have 8yz minus 3yz. So 8 minus 3 is 5. So we're going to add 5yz. Moving on to our little sunbursts, we have -4x squared minus x squared. -4 minus 1 is -5. -5x squared. And then we cannot forget our last term. Do not forget this poor little guy just because he doesn't have a shape. Remember that he needs to be added on there. He didn't have any like terms to work with, but he needs to be a part of the final equation. Alright, so that is our simplified version. Looking through this, is there any way we could simplify these further? Are there any other matching terms that we somehow missed? The answer is no, so this is our final answer. Alright, you're going to have a set of problems to solve that are going to look just like the ones we just did. Remember, you only have to solve the odd problems, but if you feel like you're struggling, then feel free to solve the even ones as well. I'll see you in the next one.